All right, it's on. Welcome, everybody. Happy New Year. I see that Yuval's got a couple of topics on the agenda. Take it away, Yuval.
Hey, so one topic is regarding the work on syncing topics and notifications. This is the work that Kunal is doing. I'm not sure if he's on the call. I can raise the issue. I mean, there'll be tons of discussions on the work. He did tremendous amount of work there. There's one small thing that I wasn't 100% sure about. This was like my last comment, so maybe I can bring that up and we can discuss that and follow up with him offline if he's not on the call. So the issue is with the updates, and this is also because I'm not 100% knowledgeable as for how the metadata sync updates are done. Um, so uh, the the zone where the information is sent to. So there is like the last bit that is working on is to maintain a list of buckets that are using a specific topic. So this is like a mapping between there's an object. It has an OMAP. It doesn't have anything other than the OMAP, and the OMAP is a list of buckets that are using this topic. And this is useful for how to update all the identification of the buckets if something changes the topic, or kind of cascade deleting and updates, and also for debuggability and other reasons. So the question is how to update or what is required when you're updating this list of buckets for the topic. And what I wasn't sure is, so in the code you can add buckets to this OMAP and remove buckets from the OMAP. Um, but I was like, my fear was that there are like multiple places that can get updates, and they're all going to do this work, and I wasn't sure how things are being synced. So how do we enforce atomicity on these actions? Now, I had a chat earlier with Matt, and he raised a point that the in the case of metadata, it's there's only one zone that is doing the. It's like there's no active. There's like only the main zone of the zone group is doing the updates, and everybody else is forwarding the updates to them. But I wasn't sure what's going to happen in the zones that are being synced. As for what if multiple RGWs are going to try and update this this um, um, this OMAP of this object, and what if like they're going to get deletions and additions of the same bucket, and things could be reordered, and I'm not sure that the final state is going to be identical to the one in the master zone. So that's my concern there.
Yeah, so, right, Rados makes this difficult since it's this list object is a separate Rados object than the metadata one, so we can't necessarily get atomic updates to both at the same time for strong consistency. But this model is very similar to what we do for bucket metadata and the users lists of buckets.
Okay.
It's essentially in OMAP also, and it's also not perfectly consistent.
But there's a metadata update, right? That also, so that's the point about it to me, though, that going to the primary is true, but you can't make a transaction out of the two updates of the two different objects in any zone.
That's right. So if we assume that only the metadata master zone is changing things, then other zones will only see changes from metadata sync, and metadata sync will only, it won't race to update a given metadata object with itself. So that seems fine. But there is some complication around how we handle requests to change metadata on secondary zones. Like, I guess it would be put bucket notification to change a policy. You can send that to a secondary zone and we'll forward it to the primary. The primary will apply the write, but the secondary will also apply its write. So that write could race with metadata sync.
So why the secondary is going to apply the right as well? I mean, the way that they wrote the code is that they forward those requests to the master zone.
Right, and so forwarding to the master would write it and write a metadata log entry, and the secondary would eventually sync it.
Right.
But we also apply the write on the secondary during the op for read after write consistency. So like if you do put bucket notification and then query the bucket notification right after, then you should get the results of the put. If we just wait for metadata sync, then there would be a delay between that.
Okay.
That's an interesting point that's not well documented in RGW. I think that's a little troublesome, but
yeah, that is a guarantee that we've provided so far. I think we could discuss whether or not we want to keep doing that, but I'm pretty sure that that's the.
We might make it optional or some future point. But yeah, okay. Interesting.
Okay, but other than this problem, the let's say a zone that wasn't involved in initial writing, so they're just getting the sync from the master zone. But couldn't there be an issue of reordering? Let's say that the master zone got like a create and then a delete, and my fear is that could that be that because the zone that is being synced could have multiple RGWs that are doing the syncing, there could be reordering issues.
So, well, metadata sync doesn't distinguish between create and delete events. It just sees that there's a mdlog entry for this bucket, and it will try to fetch the bucket. If it succeeds, then it'll overwrite the local version with what it fetched. And
Okay.
if the fetch returns 404, then it will delete its local copy.
Okay, I see. Okay, so it always it always looks at the current state. It doesn't get like an operation to perform a specific.
Exactly right. And so metadata sync is just trying to write what it read from the master zone, and it'll read its current copy and runs the logic to see what changed, and the notification object would be updated in that path. Sorry, the topic OMAP object.
Yeah. Right. Okay, I got it. Okay, then I think then that makes sense. So that probably it probably should be okay with this. Although, okay, I'll have to look again at the code and see what's going on there, because they're doing like a diff between two things, and from the diff they want to infer what's need to be added and what's need to be removed. So that sounds different than what you described, but I'll probably have to look at that again.
I don't see a problem with that model. I mean, when we overwrite a piece of metadata, we also know what version we're overwriting, and that's where we do the comparison and calculate that diff.
Okay.
So yeah, I do think the PR is on the right track. It seems to be essentially what we're doing for the user buckets list, which is not perfectly consistent, but I don't think we've really seen consistency issues there.
Yeah, I understand that. And also, I mean, again, races would be a bit uncommon because, like, we're not talking about, we're talking about metadata information update. So it shouldn't be under, like, very heavy load of updates and changes. But, I mean, what I mainly want to try to figure out is know exactly like what can or what we can or cannot guarantee. So later on, if something does happen, then at least we can rationalize and say, okay, these are the limits of our consistency model, and that's it.
Yeah, I guess the one thing that we do have for the user buckets list is the Rados GW admin bucket link and unlink commands, which you could potentially use to repair if there is a consistency issue. I don't know if it's worth doing for this topics thing because it's not a requirement for the feature itself. It's more for visibility with admin commands.
Oh no, but it also is okay. So one reason is visibility with admin commands, but there's also a functional reason, and this is the cascade delete and update. So if we want to, if, like, for example, if you delete a topic, you want all the notifications on all the buckets that use this topic to be deleted. So for that, this is not only for the debuggability or observability reason. This is also a functional reason. Same with updates. Let's say that you want to change a topic and redirect that to a different broker because, I don't know, the broker is down. Then you want that to happen on all the notifications, that you don't want them to keep on sending to the old broker. So the cascade update and delete is a functional reason, and at some point I think you suggested that we would use a lookup mechanism instead of copying the configuration down to the notification level. But I think there was some discussion around that, and we decided eventually to keep the copy model and not the lookup one.
Okay, I would like to discuss that further. Maybe we'll keep that in the PR discussion for now.
Yeah, I think when we did the discussion of the PR, at first there were like, you know, the argument was performance, but I think you kind of convinced us that this is not a strong enough argument, but there was some other reason. So I need to look up at the PR, but the discussion is there.
Okay. Well, okay. I am a little concerned about the cascade delete idea also, if it means that a operation on the topic has to visit a potentially unbounded number of buckets, since the bucket metadata rights are expensive also. But let's follow up in the PR.
Yeah, okay, we'll follow up there. Okay. Yeah, that's the kind of the question I had regarding this issue. I also have a different issue to discuss, unless we have more about this one. So the other issue is it actually came from people asking about non-persistent notifications. Now, I know that we keep on saying that you should use persistent notifications, but apparently there are use cases, or there is at least one use case to use non-persistent notifications. And the issue with this is that we need to be able to propagate back an error when the endpoint is down and not responsive. And currently we don't do that, because currently with non-persistent, so with persistentification we do the reserve and then commit. So reserve is checking that we have enough space on the queue. We put on the queue, and from there on we keep on trying the authentication as much as we can to get it through. So we don't care if the broker is down, we would still keep on trying the authentication. Now, with the persistent authentication, there was no reserve stage. It didn't do anything. And the commit stage was the one that was sending the notification out to the endpoint. And at that point, we cannot fail. I mean, we can fail, but there's no point in propagating the failure back to the client, because let's say it's a put object, so it already happened. So we can't tell the client that the put object failed because it didn't. So what I did there is that I kind of latched on the reserve commit model, and what I do on the reserve stage is try to make sure that the broker is there. So it cannot be like 100% thing, but it should be covering most of the cases. Just in general, just to make sure that people are okay with the idea that the reserve stage, so the reserve call is happening before we actually do the operation, like the S3 operation, so that the reserve call is the one that would check that the other side is probably up and responsive, and then fail and actually propagate back the error if it's not. And then when we do the commit, we actually do the sending, and most likely the sending will be successful. It's not 100% guarantee, because it could be the broker just went down or some other thing, but in most cases it would cover the problem of propagating back the whether the notification will be sent correctly or not. So that's kind of the main idea there. So if you have any concerns or something that you don't like about that, so this is like my first question.
Well, maybe I'm confused about the different modes that we have for notifications, because I think there were at least 3, but persistent notifications was the version that was like gave reliability guarantees.
Yes.
Right, which means that we do have to return an error to the client if we can't. But I thought that the other modes were more permissive.
Okay, so we actually have like two kind of things there. Like, one is whether the client, or like there's one thing that we call an ACK level. So, and you can set notification to ACK level none, which means that we don't care if the notification went through or not. So this is one thing, and it's a topic level configuration, so you can decide whether a certain topic you want an ACK level, so you actually want an ACK, or it's like a fire and forget notification, and it's like you don't know if it got there or not. So this is one thing.
Does that apply to both persistent and non-persistent cases?
Yes.
Okay.
Now in the persistent case, well, you know, it's there, but it doesn't make lots of sense. So what's the persistent case? The persistent case is that when you're when you decide that you will need to send notification, you're not really sending the notification. You're just writing that to a queue, and then there's a background thread that keep on trying to send the notification, and if it fails, it just put it back in the queue, or don't delete it from the queue, and retry that later. So in the persistent notifications, you usually would not set ACK level to none, because the whole idea is that you want to be able to survive through failures of the broker and so on. So, like, even if the broker crashed and it's down for like 5 minutes, okay, you're going to fail for 5 minutes, but then everything is safe and sound in your queue, which is a Rados object, and a persistent queue, and then you're going to retry that, and eventually the notification is going to be sent. So far we had like the ACK level, and we had the two modes. The thing with the mode which is the non-persistent, so everything is sent synchronously inside the operation, was that you send notification after you've done the operation. So whether it's a put or delete or anything, and at that point, let's say that the broker is down. Well, we log a message to the debug log, but we cannot tell the client that a problem happened. Now, if they want retry and everything, if they want us to do the retry, then they should use persistent notifications. But if they don't want us to use the retry for various reasons, maybe they want to do the retry, maybe then the notifications need to be in real time, and otherwise they don't worth it. So in this case, they don't want to do a retry, but they want to know that the failure happened. So in all these cases, we can't really reply back the correct answer, because like the put was okay and the send of the notification failed, so we don't know what to reply. So in order to cover this case, I added the option to in the reserve, which means before the actual S3 operation, to try and make sure that we can reach the broker or the endpoint, and if we cannot, then we fail and tell the client, you ask for notification, you ask for ACK level, which is not none, then the operation failed. So we never did the put object that you asked for because we were not able to send notification that was required. So that's the new functionality that I'm kind of I want to add now.
Okay, I guess I'm trying to understand this in the context of the initial modes that we designed. What is the use case for wanting reliability but not the persistent notifications?
Well, it's a matter of timeliness of the notification. So if the system is if the system wants notification, it wants us to send notification, and to do whatever we can in order to send it, then they don't mind that we send it an hour later. Okay, they'll be happy that we did all the effort of retries and then reconnect and everything and send that an hour later. And this is what persistent notifications are for. But the non-persistent notifications means that everything is sent synchronously with the operation, so they would know that really close to the time the operation was performed, the notification will be sent. And not only that, they would know that if there was it wasn't possible to do that in a timely manner, then the notification is not going to be sent and the operation is going to fail.
So when the message broker is down in synchronous notification case, then all the S3 requests from the client will fail because
Yes.
message broker is not available.
Right. So, well, which is not very different than the current behavior. So the current behavior is because everything is sent synchronously. What's going to happen is if the message broker is down and you didn't define persistent notification, so you define the synchronous notifications, what's going to happen is that all of your kind of worker threads for the front end are going to be stuck because they're going to wait and for some timeout to happen before they kind of bail out, and then the client's going to be stuck until something decides that there's no point in retrying the message anymore. Which is even worse than an immediate failure telling them that no, that's not going to go through. This is why we really encourage people not to use this mode because of this problem, and this is kind of one of the things that I want to avoid. So at first, it wasn't an issue because we had push notifications, and it's a much better mechanism. It makes more sense. But if the timeliness of delivery of notification is critical, and a late notification is better not sent, then this mode does make sense. And if it does make sense, I mean, we support it anyway. But if we support it and people are actually going to use it because it would make sense for them, then it would need to work properly, because it doesn't work properly right now.
So just to understand, for the synchronous notifications, the current behavior is there's a timeout, but even there's a timeout, the client request will stuck.
Yeah.
Okay. I see.
Yeah. Well, I mean, currently, if you use synchronous notification and you have a Kafka outage, you're not going to get service. You're going to get stuck for a long time, and nothing's going to go through. Even things that don't require notifications are not going to go through because we're going to take all of the resources. They're going to all be pending and waiting for the answers. Now, with this fix, it's like, let's say you have notifications for 10% of your requests, so you're going to 10% of the requests, you're going to get an error back immediately. You're going to get an error back to the client, and all the rest of the 90 that doesn't require notification is going to go, without any interference.
So is that by design? A synchronous notification is not honoring the timeout. Let's say the client set a 2-second timeout, and within 2 seconds, we couldn't deliver the notification to message broker. Why don't we simply fail the request, sending okay, not okay, or service not available, rather than indefinitely getting stuck in that state? So is that a design decisions, or that part I'm kind of missing?
So the current behavior is like, it was a bad design decision, but because this mode was never heavily used, then people prefer the persistent notifications, and we didn't have any feedback or a reason to think that there's an issue there. Now that there are kind of use cases for the idea is to fix the implementation. I mean, if the broker is up, then there's no big issue there. But if the broker is down, then this is really very harmful for the whole setup.
I mean, overall, immediate failure is better than indefinitely getting stuck. But yeah.
Yeah. I mean, one thing that we might say, I'm not sure if this would be needed, is to kind of indicate whether we want to fail the operation. But I mean, if you don't want to fail the operation, then don't set the ACK level to none, and then you don't care if the operation went through or not. If you set the ACK level, then you kind of hinted that you want the notification to be sent, and you care about that, and you want to fail if it cannot happen. Yeah, so that's the change that I plan to do there. In the case of Kafka and MQP, I'm not going to send anything, but I have like internal state that is based on the background thread that does the Kafka or MQP, and figure out whether the connection is good or not. We also have an HTTP endpoint, and there I'm not sure exactly what is the right approach to kind of ping, quote unquote, the HTTP server to see if it's up or not. So I'm more open to ideas here. I'm not sure what is the right thing there. And I mean, anyways, I'm going to put this PR for review. I just wanted to give the context because it's not straightforward to understand why I'm doing that. And I mean, if you have concerns and issues with at the design level, I'm sure you can express that in the PR as well. That's all for me.
All right, thanks, Yuval. I see that Krunal joined, so we might pick up some of the discussion that we started about the sync of notifications.
Yeah, I kind of missed the discussion actually. Yeah. I'm guessing
Yeah.
you all had some concerns about using the OMAP versus the CLS OMAP.
Sorry, my question was with the atomicity of the OMAP operations. If you have like the way that you do that, you look at the you do a diff between the two maps to see which buckets need to be added and which buckets need to be removed, right?
Um, so it will be still a single bucket because that call is called for a single bucket. So it's basically that call is followed by merge and sort attributes, which is called on a single bucket at any given point of time. So basically it's adding or either adding or removing that bucket from the OMAP. So it's just essentially just removing one single bucket from that OMAP list.
Okay. Yeah. Okay. So, I mean, let's say if the master zone kind of added and removed the bucket a couple of times, what would you see in the zone that is doing this, that is syncing itself? Like, would you see the different operation, or you just see the like what's going on with the OMAP of the object and reflect that? That was my kind of question.
So you're saying there will be an S3 operations if a user does back-to-back S3 operations, which is adding a notification and then removing it, like
Yeah.
adding it and removing it right away on the master zone, right?
Yes.
So if these are metadata sync operations, I'm guessing they should be in sync. Correct me if I'm wrong, Casey. So in that case, the first time when the user adds it, so when it comes all the way to the notification, you will only be adding that bucket to the OMAP object, basically. So the topic object will now have a bucket associated to it. And then the subsequent call where the S3 call where the user is now removing it would then get synced to the secondary, and then secondary would go and remove it. So it would not be it'll be two separate calls, one for add, one for remove.
Right, and it's possible that if sync is delayed, it doesn't see the intermediate step and only sees the change that removed it, in which case it didn't add anything, so it doesn't see anything to remove, and I think that stays consistent.
Okay. Okay. That was my question then. Thank you.
So then we should be good with the OMAP object, right? As is, or you still want to?
No, I think we're good there then. Yeah.
Thank you.
Yeah. There was another question that we discussed over the PR, but I don't remember the why we made the final decision. And this is something that Casey brought, and this is regarding the cascade delete and update. So why do we want to copy the configuration over from the topic to the notification and not do an extra lookup?
Didn't we solve that? I mean, I thought so. The idea was Casey had the idea like we don't want a topic update to trigger a metadata operation update on bucket because bucket, so the entire bucket instance gets updated, so it kind of invalidate cache. That was one of the reason. And then due to RGW crashes, you didn't want the topic updates to be inconsistent. Like if the topic gets updated, but then those notifications are not updated in their topic. So I kind of remember those two were the reasons for us to look up. And then we had the concern that this was in a fast path, so lookup should be a problem. But Casey suggested that the cache should be pretty good enough. If the topics are not updated, the lookups, subsequent lookups should be faster. Even though if they're in the fast path, we still go and load the topic from the Rados rather than storing them inside the bucket notification.
Okay, so eventually we decided to go with the lookup.
That's correct.
Oh, okay,
Yeah,
okay.
may-
Sorry. Yeah,
maybe-
I got it wrong. Sorry.
Maybe Yuval and I are just confused about your comment 2 weeks ago. I linked it in chat if you can access that. Sounds like
Sure, let me take a look at them. Yep.
Sounds like we're maybe still copying some topic stuff in the notification.
So yes, we do copy that, but then that topic is, I mean, that's just for looking up the queue name and stuff like that. But the actual configuration of the endpoints so ideally you want the entire endpoints and the other configuration that does the actual notification thing. And for that, we still go and look up. So we still copy the topic into the notification, but that's only used for queue names and for looking up the actual name and stuff like that, but not for actual sending of notifications, which
Okay,
was, yeah.
Okay, and that's not going to change, right? Because the name of the queue and the topic is
Correct. So the name of the queue is, once it is there, it stays there. So it's kind of, we go and update that name. We don't change that name, but we still can go and update the actual push end parameters basically.
Right.
So that could change, and so that's the reason we go and actually load the topic before sending the notification, actual notification.
Okay. Okay, that sounds great then.
Cool. Thanks for clearing that up.
Perfect. Yep.
All right. Any other topics for discussion today? Let's call it here then. Thanks, everybody. See you next time.
Thank you.
Bye.
Bye-bye.